is covering section 1.3 in our trigonometry book. We will be looking at the Pythagorean theorem and using it to calculate distance, which will help us start to understand trigonometric functions. We talked last week about angles being in standard position. We said that the initial side of the angle had to be on the positive x-axis. So we see here is the beginning of the angle. And then opening counterclockwise, we get this terminal side over here. Now, the distance that we have moved to create this point P right here, which is on the terminal side of the angle, has x as its first coordinate. Even though this is moving from the origin in a negative direction, we're just going to consider this to be x right now. We're talking about this distance right here, and then we've got y here. Those are the two coordinates that are getting us to that point P. You can see that there's a right triangle that's created, and what we want to know is the distance of the hypotenuse of that triangle. It's labeled R because eventually what we're going to do is we're going to have a circle that is drawn. Some of you may remember from high school the unit circle, and it's going to be, that R is going to end up becoming the radius of the circle. So to find the length of R, we're using the Pythagorean theorem. The Pythagorean theorem states that if I have a triangle like this, and this side is x, this side is y, and I want to figure out what this side is, we talked about it last week as a squared plus b squared equals c squared, and that a and b could be interchangeable, but c has to be the hypotenuse. So making an exchange here, we'll say a variable exchange. Let's say that this is in the position of A, and this is in the position of B, and this is C. We'll rewrite it as x squared plus y squared equals r squared. Because instead of being C, we're going to have that be r, the eventual radius. If I take the square root of both sides so that r is by itself, then I get the formula that I'm seeing over here. We have x squared plus y squared under the radical sign and then equaling r. So this formula is what we will use to find the distance to any point from the origin. Now we get to the part where we are going to define what the trigonometric functions are, and they are based on a right triangle with the sides of the triangle be labeled the way that we just saw in that last picture. So if I were looking at an angle, let's say in the first quadrant, the triangle would go this direction. The angle is always going to sit right next to the origin, and the right angle is always going to be touching the x-axis. This coordinate will always be x, this coordinate will be y, and r is in the position of the hypotenuse. The first function that we see, sine of theta, again remember we said that this little Greek symbol is called theta. It's just a variable that we use for an angle. And the three letters you see, S-I-N, that's shorthand for the word sine, S-I-N-E. So the sine of the angle is y over r. We take whatever the number is in the position of y, and we divide it by whatever number is in the position of r. The second function is called cosine. Each of the three letters that you see are an abbreviation of the function name. This one is called tangent. This is called cosecant. This is called secant. And this is cotangent. Now, a couple of things just to notice. One is that these two guys are reciprocals of one another, meaning that if you look at the fractions and flip them upside down, they are reciprocals. Same with these, and same with these. These are reciprocals, right? So most of the time, we really only have to think about finding the first three, the top row, because we can get the other three for free. And eventually what we're going to work towards is having to only find one of them, and we can get the other 5 for free. If you know one, you can figure out what the other 5 are. The other thing that you should probably take note of is that each of the functions have another function that has the word C, or the letters CO in front of them. I have sine and cosine. I have secant and cosecant. And I have tangent and cotangent. So there are different relationships that we will talk about in a couple of weeks where these are called the co-functions, just literally because they have co in front of them. In this example, we're going to find all of the function values for a given triangle, all 6 trig functions. The triangle is drawn for us. The point was 8, 15, and so we can see that the point is plotted. That tells us that the x coordinate is 8, the y coordinate is 15, and to get the 17, the Pythagorean theorem was used, right? So this length here is r. So r was the square root of x squared plus y squared, or r is the square root of 8 squared plus 15 squared. Plug that into your calculator and you'll get that r is equal to 17. Now, the sine of the angle is y over r. So that will be 15 over 17. The cosine of the angle is x over r. I'm just using those formulas that we had on the last slide, those definitions. The cosine of the angle is x over r, so that would be 8 over 17. And the tangent of the angle, this is not multiplied, it's saying the tangent of the angle theta is y over x, or 15 over 8. Now on the slide before, we said that they're set up one on top of the other in terms of their reciprocal values. So the nice thing is that once you find the first 3, you can find the other ones pretty easily. The cosecant is the reciprocal of the sine. It's r over y. And I just take the fraction I found originally and flip it upside down. Secant is the reciprocal of cosine. So it's r over x, or in this case, 17 over 8. And then the cotangent of the angle is the reciprocal of tangent, or x over y. In this case, it'll be 8 over 15. Those are the 6 trigonometric functions for the angle theta, whose picture is drawn on the left. A common mistake that students make when they first start learning about trig functions is that they think that these two are reciprocals and they think that these two are reciprocals because they both start with a C and they both start with an S. So this is just a note to remember that sine goes with cosecant and cosine goes with secant. All right, here's an, skip that slide. All right, here is another example of a point. In this case, the point is in the third quadrant. the coordinates are -3, -4. But similarly, we will use the Pythagorean theorem to find the length of the hypotenuse. There was a triangle here, right? And if we use that Pythagorean identity to find r, -3, remember to put in parentheses before you square, plus -4 squared, and you'll get that r is equal to 5. What's happening in the Pythagorean theorem is we're taking a number and we're squaring it, which makes it positive, and then we're adding them together and then taking the square root, so it sort of undoes the squaring process. But you want to make sure that the negative sign is included, if you're using a calculator, included in parentheses so that that whole number becomes positive. If you type into the calculator like this, it'll give you back -9 because it'll only square the 3 and then it'll throw the negative sign in front of it. So we don't want to type it in like that. Okay, so now that we have the different values, we can find the trig functions. So the sine of the angle is y over r, or -4/5. The cosine of the angle is x over r, or -3/5. Again, this is the x value, this is the y value, and this is r. And the tangent of the angle is y over x, or -4/3, which simplifies to 4/3. The cosecant is just going to be the reciprocal of the sine, so it'll be -5/4. The secant is going to be the reciprocal of cosine, so it's going to be -5/3. And the cotangent will be the reciprocal of the tangent, so that's 3/4. What if we have a point that is not in the middle of one of the quadrants, but it's actually on the axis? We said that the name for those specific types of angles are called quadrantal angles, and in this case they just picked a point on the y-axis, 0, 1. So in this case, x is equal to 0, y is equal to 1, and if we plug into our formula here, we get that r is also equal to 1. So our sine is y over r, the cosine is x over r, and the tangent is y over x. So here we have 1 over 1, which is 1. Here we have 0 over 1. 0 can be divided by 1, that's okay. Plug that into your calculator and it will tell you that the answer is 0. Y over x is 1 over 0. This one's not okay. We're not allowed to have 0 in the denominator. If you plug that into the calculator, it'll give you an error and tell you that it's not okay. So this one is undefined. We say undefined. The cosecant is the reciprocal, so this will also be 1. But for the secant here, going back to this fraction, if I flip that upside down, I'm going to get 1 over 0, so that's going to be undefined also. It's going to be undefined because I can't have 0 in the denominator. But the interesting thing is that when I go to the tangent and I flip this fraction upside down, For cotangent, I get 0 over 1, and that's okay, that's 0. So within these pairs, you'll get one that ends up being 0 and one that ends up being undefined. And this is true anytime you're on any of the axes because either the x or the y coordinate is equal to 0. Here's a different example. For this example, we were looking at a point on the y-axis. Here at 180 degrees, this would be a point on the x-axis. And again, the point doesn't matter. In the last example, they just chose that point to be 1 away from the origin. Here, we're selecting it to be a distance of 3 away from the origin. But we can follow the same process. Let's figure out what the length of r is. R is equal to the square root of x squared plus y squared. This will give us 3. The sine of the angle is y over r, or 0 over 3, which is 0. The cosine of the angle is x over r, negative 3 over 3, which is negative 1. And the tangent of the angle is y over x, which is 0 over negative 3, so that's 0. The cosecant will be 3 over 0. That's no good. That's undefined, right? We can't have 0 in the denominator. The secant is 3 over negative 3. Also negative 1. And the cotangent is negative 3 over 0. That's also no good, also undefined. Right? So in both of these two examples, when we're either on the x-axis or the y-axis, 2 of the trig functions will be undefined. There's a chart in your textbook that has kind of an overview that you can look at. I don't think it's particularly helpful necessarily to memorize. We'll go through so many examples over the next few weeks that'll become second nature to you. If you're using a calculator, you want to make sure that when you're calculating, right now we're only talking about degree mode. We're not talking about radians yet. When we get to that point, I'll show you how to change between radian and degree mode. You want to make sure you get the right calculations. All right, that's it for section 1.3. If you have questions, you can send me an email, and have a great day.